Hey guys, today we're going to be talking about verifying trigonometric identities. Now before we get going, make sure you have your handy dandy formula chart ready and next to you as you fill in these notes. Not sure what I'm talking about? This is what I'm talking about. This is your new best friend and you need it next to you. You will have it on every quiz and test because it's not just about memorization, it's about knowing what to do with the information on that formula chart, that identity list. All right. Couple of things to know before we start. Now, when we're verifying identities, we are showing that things are indeed equal. Okay. Now, and whenever we're verifying trigonometric identities, you want to start with the side that looks a little scarier. So we're going to start with this side, and we're going to work the same process we worked last time to use our formula sheet to trade in different equations and make things easier and simpler. So let's go ahead and do that. If you'll notice, on the numerator, we have this secant squared minus 1, and one of my identities has a secant squared and a positive 1, and we know that we can trade, or we can manipulate that identity like so. Sorry guys. Like that. I can rewrite that identity as tan squared theta equals secant squared theta minus 1. Now that I know that tan squared theta equals secant squared theta minus 1, I can look for other places where I can have found this secant squared theta minus 1. Well, where can I do that? In my numerator right here. So let's start writing. My first step on this side is I know that I can replace that entire numerator with tan squared theta, and then let's just go ahead and rewrite our denominator. Now from that, what we can do is convert everything to sine and cosine, because that's where we want to go when we're done. So my next step is going to turn, I still have a fraction, but my numerator I can change tangent squared into sine squared theta over cosine squared theta. And my denominator I can change into 1 over cosine squared theta. And remember, when we divide fractions, we can do that by multiplying by the reciprocal of the second fraction. So it's going to be a fraction times a fraction. The first fraction is your numerator. That stays the same. Okay, my second fraction is going to be reciprocal of 1 over cosine squared, so it's cosine squared theta over 1. And now, because everything's multiplied, I can cross cancel, boom, boom. And that leaves me with sine squared theta over 1, or just sine squared theta, which is what we were trying to prove or verify in the beginning. Example 2 says verify the identity. When we're verifying, we want to start with the more complicated appearing side. So let's start here. And the trick we learned last notes was whenever we have a denominator with a subtraction sign or an addition sign, so a sum in a denominator or a difference in a denominator, we need to uncomplicate that by using a conjugate. So all I'm doing right this second is I'm going to rewrite the problem. And as you can see, the problem is a simple sum of two fractions. So this plus is that plus, just to make your brain see it a little bit better. Okay, and then I'm just rewriting the problem right here. 1 minus sine of a, and then 1 over 1 plus sine of a. So because it's a simple sum, we need to have a common denominator to add them, and we don't have a common denominator. They're close, and so the way we create a common denominator when the denominator is a sum of difference is we use a conjugate. So the conjugate is going to have the opposite sign of the denominator we're working with. So let's work over here. Here this says 1 minus sine A, so my denominator I need is going to say 1 plus sine A. That's what a conjugate does. That's a plus. And then to make sure, what makes this move legal is I can put it on top, and this is a version of 1, and you can multiply anything by 1, and it doesn't change. You don't have to multiply everything by 1, but you can multiply anything or any part of any equation or expression by 1, and you're good. So I multiply the conjugate over here, and then we're going to do a conjugate over here now to help clean up this denominator. I have a 1 plus sine of A, so my conjugate is going to be a 1 minus sine of A, and I have to keep it a version of 1. So there you go. That was an ugly parenthesis. I'm going to fix it. Okay. Now we got to multiply. And again, remember, this is a sum, so it's going to be the sum of two fractions. Sorry about that. Now, this numerator times this numerator is going to give you a 1 plus sine of A, because multiplying by 1 doesn't change anything. And then this numerator times this numerator is going to give you a 1 minus sine of A, because that doesn't change anything. Next, I got to figure out what to do with the denominators. Well, we recognize this as a 1 plus something and a 1 minus something is a difference of squares, and we know that difference of squares end up like this. Okay. If you don't believe me, you can just FOIL those two denominators on the left, and then the same thing will happen over here. 1 minus sine squared of A. Now I have a common denominator, so let's go ahead and do the sum. When you have your common denominator, you rewrite your denominator, and then you just add your numerators. I got a 1 and a 1 makes a 2, and then I have a positive sine A and a negative sine A, and those two go away. Now, so that's nice. So the numerator is just going to be a 2, and I'm just cleaning that up a little bit so it's in the middle. So the numerator is just a 2. Okay, now let's, I'm forgetting to put these equal signs. Let's clean up the denominator a little bit. 2 times 1 minus sine A, this should start to be familiar. That's what I want your brain to start doing. You know, if it's like, well, wait a second, have I seen this before? You absolutely have, because on your formula chart, we got sine squared A plus cosine squared A equals 1. And I can move that sine A squared to the other side, leaving cosine squared A equals 1 minus sine squared A. We have a 1 minus sine squared A right here. We have a 1 minus sine squared A right here, so I can replace it with what it's equal to. So 1 minus sine A squared, or sine squared A, can get replaced with cosine squared A. And we're almost there. Okay, now my next move I'm going to make looks a little like this. We agreed that we can multiply anything by 1 and it doesn't change. So what I want you to start to see, and hopefully this doesn't blow your minds, but I'm afraid it might, is that this step right here is going to mean the same thing as the next step. Why can I make that move? Well, when I remultiply it, it's the same thing. Now we're almost done. 1 over regular cosine is a regular secant, so 1 over cosine squared is going to be a secant squared. Okay. And then multiply it by that 2 in front, and you should have verified your identity. Yep. There you go. Example 3, verify the identity. Start with the scarier side. Boom. Then we're going to put equals. Now, let's see if there's anything on my list. Well, first off, the identity is a product, so it's two things multiplied by each other. And see if there's anything on your handy-dandy formula chart that can help you immediately, and there is. There's this identity that says 1 plus tan squared theta equals secant squared theta. Okay. And do I have a 1 plus tan squared theta? Yep, I sure do, so check it out. I got a 1 plus tan squared here, and I got a tan squared x plus 1 there, and those two things can get swapped out for this part right here, so that first whole parentheses turns into a secant squared x, not a theta because there's an x in the problem. Theta's from the formula chart. And then I got this cosine squared x minus 1. What I'm going to recommend you do is to factor out a negative 1 to turn it into a version of our other go-to trig identity, which is going to be a 1 minus cosine squared x. Next, what we need to do is the following. I'm going to rewrite my first fraction, or my first term, secant squared x, and then my inside parentheses over here, we always need to ask ourselves, is there something on my formula chart that I can replace this with? Well, you bet there is. Because remember, if sine squared x plus cosine squared x equals 1, then I know sine squared x equals 1 minus cosine squared x. So, what's in common? What matches up? I know 1 minus cosine squared x is there. Here's a 1 minus cosine squared x, and I can replace, anywhere I see that, I can replace it with a sine squared of x, so that's exactly what I'm going to do. The sine squared x. Now, to finish our identity, we have one of my two terms in terms of sine and cosine, so another strategy is convert to sine and cosine and see where we go. Secant is the reciprocal of cosine, so this turns into 1 over cosine squared x. You see that we've created a fraction, so let's just turn this into a fraction. 1 is the universal denominator when in doubt. And then combine them, top times top, bottom times bottom, so I have a negative sine squared x over cosine squared x. And then we know that sine over cosine is tangent, so a sine squared x over a cosine squared x is an tan squared x, which is what we are after. Example 4. So on the left side, I have a sum, and on the right side, I have a product, meaning two things multiplied. And generally, you're going to want to, adding and subtracting trig is going to be trickier than multiplying trig. So the trickier side that we learned today that we need to start with is this one. So let's get going. One step is to convert to sine. One approach is to convert to sine and cosine. So I know tangent is sine x over cosine x. Again, it's something plus something else. Something plus something else. And cotangent is just the reciprocal of that. Now, to add fractions, I need a common denominator. So let's do that. Here, when you have two different denominators, one way to, the easiest common denominator to find is the product of the two denominators. So one side, so on the sine side, I'm going to multiply by cosine x over cosine x. And on the cosine side, I'm going to multiply by sine x over sine x. And again, you have to keep it a version of 1. Now, we need to multiply. We got a sine x times a sine x, and that makes a sine squared x. And then on the bottom, it's going to be a sine x times a cosine x, so we're going to have sine x cosine x, and they just get stuck together. Let's go to the right side. On the right fraction, that's going to turn into, well, I got a cosine x and a cosine x, so that's going to be a cosine x squared, or cosine squared x, excuse me. And then on the bottom, you just multiply the denominators, sine x cosine x. Not bad. Now, we did all that work so we can get common denominators. We have common denominators, so let's go ahead and combine them. Whenever you have a common denominator and a sum of fractions, we'll go ahead and rewrite the denominator and then combine your numerators. They are not like terms, so you just list them separately. And a little alarm should start going off. Like, wait, I've seen that before. Where have I seen it? It was on your formula chart. And on your formula chart, I know that sine squared x plus cosine squared x equals 1. So anywhere I see sine squared x plus cosine squared x, like here, I can replace it with a 1. So that's going to be my very next move. And then, remember, we can multiply anything by 1. And so I'm going to split this one fraction into two fractions. 1 over sine of x times 1 over cosine of x. Wait a minute, we have names for those. 1 over sine of x is cosecant x. 1 over cosine x is secant x. And wouldn't you know it, that's exactly what we're trying to verify. I flipped the order, but when you multiply, you can 2 times 3 is the same as 3 times 2. And then I forgot my equal signs all the way down. My bad. Do as I say, not as I do. Example 5, verify the identity. I'm going to start with the right side. That looks scarier to me, and it's not just a matter of taste. It's scarier because the left side is a simple sum. The right side has a difference in a denominator, so there's two bad things happening. We have a denominator, so we have a fraction, so that's a little icky, and then there's a difference in the denominator, so that's double trouble, if you ask me, but we can handle it. So let's start with what I know. Whenever you have a difference or a sum in the denominator, the trick we know is to multiply by the conjugate. And a conjugate is the same. You keep the denominator the same, but you change the sign. So instead of 1 minus sine, it's a 1 plus sine x. And to keep it a version of 1, to keep this a legal move, you got to put it on top 2. So because we know difference of squares, my denominator is turning into a 1 minus sine squared x. And my numerator, I'm going to keep it factored like this for now. Now, alarm should be going off in your head because you say, wait, have I seen a 1 minus sine squared x before? Yes, it's a version of the Pythagorean identity, sine squared x plus cosine squared x equals 1. What version is it? Well, subtract or move the cosine or the sine squared x to the other side, so you get cosine squared x equals 1 minus sine squared x. And what that means is anywhere I see this, like here, I can replace it with this. So let's go ahead and do that. So my next move is going to be cosine squared x on the bottom. And then I'm going to rewrite my numerator, cosine x over 1 plus sine x. Next, cosine squared on the denominator really means a cosine x times a cosine x. So let's write that out just to help you see it. I'm going to rewrite my numerator. Then, hopefully you can see I have a product on the top and a product on the bottom. And when I have that, I can cross-cancel some stuff out. So what am I left with? I'm left with a 1 plus sine x over cosine x. Now, this is actually already combined, and so what I want to do is I want to uncombine it. It's supposed to be no. How do I uncombine it? Well, it is a sum because of this bad boy, so let's separate it into the two fractions that it used to be before it got combined. Here's how you do it. so it's going to be a fraction and a fraction. We had our if it already got added, it had a common denominator of cosine x, and the first one goes first, and the second one goes second. Almost there. Let's clean it up. Let's make it sleek. 1 over cosine x is secant x. Sine over cosine is tangent x. And is that what we're verifying? Holy moly, we did it. Yay. Example 6, verify the identity. Now, this is a little bit different approach. It's going to be the same idea, but what we have been doing for the previous 5 examples is show that one side equals another side. What we're doing on this one is that we're going to manipulate the left side and the right side at the same time to show that they equal the same thing. You'll see what I mean in just a minute. So we're going to, let's start with we're going to manipulate both sides in just a second. So we'll have a boxed side and a clouded side, and it doesn't matter which one you start, but here's what I recommend we do. Let's start on the box side because it's on the left. Why not? So let's write it like this. I'm going to put this in parentheses just so you can see what we're doing. Now, and eventually I'm going to show you that this boxed value gets simplified to the same thing that this cloud value does. So we're going to leave that placeholder right there. So let's start on the left side. I have a cotangent squared x in my numerator right here. So always I want you to look at your handy dandy formula chart and say, hey, is there anything I can swap out for that? And in fact, there is. Cotangent is on my Pythagorean identity, and the identity that we have here is 1 plus cotangent squared x equals cosecant squared x. Okay, well, so that means I can make my cotangent squared x equal cosecant squared x minus 1. So everywhere I see a cosecant squared x minus 1, I can replace it with, everywhere I see a cotangent, I can replace it with, so here's a cotangent. Everywhere I see a cotangent, I can replace it with a cosecant squared x minus 1, and that's exactly what I'm going to do. So we have this fraction, and then instead of cotangent squared x, I'm going to put cosecant squared x minus 1. And I'm going to leave the bottom the same, 1 plus cosecant, actually, it says x, my bad, we'll do theta. Okay. Now, what hopefully you're seeing is you have a square minus a 1, and that's the difference of squares. So we can factor that into a something plus 1 and a something minus 1, and the something is cosecant theta. And that's just my numerator, and my denominator, I have a 1 plus cosecant theta, or can I also write that as a cosecant theta plus 1? Isn't 1 plus 2 the same as 2 plus 1? It sure is. So why did I do that? Well, hopefully you can see it. Boom, boom. So I can simplify my original left side of my identity to cosecant theta minus 1. And that's as simplified as I can get it. So the left side simplifies to cosecant theta minus 1. So that means my right side right here is going to also have to simplify to cosecant theta minus 1. If it does, then that effectively verifies our proof, and that's what we're about to do. So let's start on the right side and go from there. On the right side, what I want you to see is this. Let's start with red. So we have 1 minus sine theta. So I have a difference in the numerator on this right side. Well, what I want our first move to be is, and I'll go ahead and rewrite. Let's just rewrite it. 1 minus sine theta. And guys, I'm using the parentheses just to help your brain and your eyes catch it. I did no math there. That's all just rewriting it. Now, this is a difference in the numerator means it was a difference of fractions. So let's break it into the two fractions that it was. And since it used to be a difference and it had a common denominator, I'm going to do sine theta. And my first term goes first, and my second term goes second. Well, what do you see in this second term? Sine at an angle over sine of an angle. We all know that anything divided by itself is 1, so that turns into 1. And what do you know about 1 over sine theta? It is cosecant theta. And wait, that's familiar. Why is it familiar? Well, cosecant, the right side gets simplified to cosecant theta minus 1. The left side gets simplified to cosecant theta minus 1. And so just like 2 equals 2 or pi equals pi, we know that the right side equals cosecant theta minus 1. Guys, I'm proud of you. It's hard work, but it's good work. Keep up the good work.